You will often encounter a binomial times itself, but it usually won't look like this. It will look like that term squared. These sometimes can be tricky because students will think that you're really going to apply the exponent to each term in here. But when we are squaring a binomial, that looks like this. We're taking the whole binomial times itself. So each of these two here really need to be re-expressed and FOILed. So when you look at 3x minus 5 squared, that's really 3x minus 5 times 3x minus 5, and x minus 3y squared would be x minus 3y times x minus 3y. So just be careful when you see something that looks like this. It's really this in disguise. And we will just go about foiling the same way that we've done before. X times x is x squared. X times positive 4 would be positive 4x. Positive 4 times x would also be positive 4x. And positive 4 times positive 4 would be positive 16. Note that because of the structure here, an x to the first and a constant, an x to the first and a constant, we will be able to combine the terms in the middle. X squared plus 8x plus 16. Likewise here, we're going to take 3x times 3x, and that will be 9x squared. 3x times negative 5 would be negative 15x. Negative 5 times 3x would also be negative 15x. Same thing is happening here too. Negative 5 times negative 5 would be positive 25. Because of the structure here, we are squaring something. That means the first two terms and the second two terms are identical. We're going to be able to combine the center terms. In this case, we would rewrite as 9x squared minus 30x plus 25. Last example, same idea. We would need to turn this square of a binomial into the binomial times itself so that we don't miss out on what's going on in the middle. X times x is x squared. X times negative 3y would be negative 3xy. Again, we want to keep the variables in alphabetical order. Negative 3y times x would also be negative 3xy. We have twins in the middle in every single example because we're taking a quantity and squaring it. Negative 3y times negative 3y would be positive 9y squared. And now we need to go about combining the middle terms again. X squared minus 6xy plus 9y squared. And I want us to look at the results of all of these. The first term is the first term squared. The last term is the second term squared. The middle term takes the first term times the second term and doubles it. Same thing here. The first term is the first term in your binomials squared. 3x, the whole quantity, in parentheses, to the second power equals 9x squared. The last term would be the second term squared. Negative 5 times negative 5 is positive 25. And the middle term is going to take the first term times the second term and then doubling it. Same thing's going on here. X times x, so we're going to take the first term and square it. The last term would be the second term. Negative 3y times negative 3y would be positive 9y squared. And then the middle term is going to take these two terms multiplied together, negative 3xy, and doubling it.